Are you able to see the slides? And you got the assignment. Okay, but slides not visible. Okay, so look at the first question. Your first question says that you have to find the minimum collapse fault list and the collapse ratio. For I have for the for so for the equivalent faults are always patterns able to detect the fault. Talk about the as A, B, output as C, then set of all inputs to be able to test zero fault. To set a zero fault to be initiated, you have the actual value as 1 and the faulty value as 0. Okay. So value of 1, I have the possible terms as 1, 1, 1. So problem that is deeply only when the input from his side is 1. How to detect this at 0.8 unless the whole 1. Here B, it is for here. When the other but we are currently so this pattern which gave me this is all the one and I collapse force is will be started following but get zero out. In these force. Now this is the one for this also second one this also 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 faults maximum, right? Of which we'll collapse the equivalent faults first. For an AND gate, we have seen stuck at 0 at inputs are equivalent to stuck at 0 at output, so I eliminate these stuck at 0 faults. When it comes to a fan, none of the faults are equivalent because any fault on B may not affect any fault on C may not affect the fault on B. Therefore, in the last slide, for the fan out, all the 6 faults should be considered. None of them are equivalent. So we keep all those faults. Looking at this NOT gate, a stuck at 0 at input is equivalent to stuck at 1 at output. Similarly, stuck at 1 at input is equivalent to stuck at 0 at output. Therefore, I eliminate the 2 faults towards input and I keep the 2 faults at. Then comes the AND gate. AND gate में वापस input stuck at zeros are collapsed. We are left with this. Then I have the OR gate. So for an OR gate, the stuck at 1 faults are collapsed towards the input and I am left with 0 and stuck at 1. So if I find the collapse ratio, after the equivalent fault collapsing, this how many faults left? 7, 8, 9, ahead. 18 is the collapse ratio that I get. How much is 10 by 18? 0.556. Right? Now proceed with fault dominance. Fault dominance means अगर मेरा जो टेस्ट पैटर्न है of F1, all the test patterns of F1 are able to detect the fault F2 as well, then I say F2 dominates F1 and I eliminate this F2 fault. So I eliminate this F2 fault if all the test patterns of F1 can detect F2 also. Therefore, if I talk about the AND gate, equivalent collapsing के बाद क्या बचा मेरे पास? Stuck at 1, stuck at 1, stuck at 0 and stuck at 1. So what tests are used to detect this stuck at 1 at AND gate? Stuck at 1 is detected with 0, 1. So the test pattern that I need to have for stuck at 1 fault here is 0, 1. Here it is 1, 0. Stuck at 0 will be detected with input test pattern 1, 1. Stuck at 1 will be detected with 0, 0, 0, 1, 1, 0. So this 0, 1 test pattern detects the fault at this input and it also detects the fault at the output stuck at 1. Similarly, stuck at 1 here. Therefore, this is said to dominate the stuck at fault at input and therefore I eliminate this stuck at 1. So after equivalent fault collapsing and dominant fault collapsing and gate, I am left out with stuck at 1 faults at input and stuck at 0 faults at output. So I proceed with the same way on the circuit. If I look at this AND gate first, the only possible faults are stuck at 1 at input and stuck at 0. That is the minimum fault list. No dominant faults are present for the time being, therefore nothing cancels out. If I look at this NOT gate, I am only available with stuck at 1 fault, so it cannot be equivalent to any of, so it remains. Again for the AND gate, I am with stuck at 1 fault at input and stuck at 0 fault at output, so that is the fault list, nothing can be done. But if I look at this OR gate, this OR has stuck at zeros at input, tested with the same pattern as stuck at 0 at. Therefore, we will be eliminated and stuck at 0. So we are left stuck at zeros at input and stuck at 1 at output. So now after dominant fault collapsing, the collapse rate is given
मैम मुझे आपकी वीडियो दिख ही नहीं रही है स्क्रीन शेयरिंग में, तो ग्लिच मेरी साइड से है या मैम किसी को नहीं दिख रही? हेलो.
So finally, when I'm trying to work out for the best test pattern to detect the fault or ATPG, when I try to apply on this combinational circuit, I'll be targeting only the 50% of the 50% of the exhaustive fault list that needs to be targeted, and those faults are here. stuck at 1 faults at the AND gate, at 1 stuck at 0 at the primary input B, stuck at 1 at the inputs of this AND gate, stuck at 0 at the inputs of the OR gate, and finally only stuck at 1 fault at the primary output J. Only these faults need to be taken care of. Fine? Any problem in this question?
Ma'am?
I am not able to hear you. Content is not visible. Yes, Purva?
मैम
Hello?
हाँ मैम अभी दिखनी शुरू हुई है, शुरू से नहीं थी और शायद 2-3 लोगों को भी ले देगी।
मुझे यहाँ दिख रही है। चलो, I'll explain you once again. Your first question, if you look at the assignment sheet.
मैम अभी भी नहीं दिख रहा कंटेंट।
अरे अब
यस मैम बिल्कुल।
अब दिख रहा है? सबको दिख रहा है?
यस मैम।
So your question is to look at it to find the minimum. So find the minimum. I need to first eliminate the equivalent fault, and then I need to eliminate the equivalent fault. Fault fault means if F1 is tested with some pattern T1, the same pattern detect 2 as well. Then we say F1 and equal. So I get you look at it later. Now we'll work for this gate. For an OR gate, if I have my input stuck at 0, input stuck at 0 means actual value 1 hona chahiye, faulty value is 0. So this is fault D. This D will propagate. I can see only the other input is 0. Right? So that the test pattern becomes 1, 0. If the test pattern is 0, I am able to detect stuck at 0 fault at 0. 0 fault at this will only be seen at the my test pattern is 0. ठीक है? तो 0 भी किस इनिशिएट करना सर if 1 तो हमेशा 1 ही रह जाए. We want the error to be propagated. Similarly, for stuck on fault, if I talk about the stuck and one fault, I need this as value. Actual value 0, fault value 1. This fault will be propagated only if the other value is 0. Test pattern it becomes 0, 0. We detect stuck at 1 fault at this. Similarly, a 0, 0 test will be able to detect the stuck at 1 fault at this input as well. Coming to the output, stuck at 0 should be 1 and the output, the fault value should be 0, which is tested. Put test pattern 1 0 1. For all three cases, output value at 1. For at 1, it is only 0 1. It means it is only tested with 0 0. So if I look at the test patterns and compare them, a 0 is the stuck at 1 faults at input as well as stuck at 1 fault at output. Therefore, to reduce the number of faults, I will eliminate the faults at input because the same test pattern can be used to detect this fault at output. So by default, वो test pattern इन दोनों को भी detect कर लेगा. So we eliminate stuck at 1 faults at input since they are equivalent to stuck at 1 fault at output. Fine. So we are left with 4 faults on the OR gate. जो exhaustive fault list है उसमें 6 थी, but अभी मेरे पास 4 रह जाएंगे. The same thing needs to be done on the circuit given to you. When we talk about the circuit, we start with the logic gates and only the fan outs. So the first the first primary input is A. A is given to the AND gate. AND gate का fault collapsing कैसे होगा? Equivalent fault अगर हम देखें, तो equivalent fault में stuck at zeros are eliminated at input and we are left with rest of the faults. So here, of all the possible faults, at every wire I have the exhaustive fault list as stuck at 0 and stuck at 1. So I have total 18 faults listed here since I have 9 wires. So 18 fault is the maximum number of faults that I can have. Right? Out of which for this AND gate, the stuck at 0 faults at input are collapsed. So I this and now doesn't have any equivalent fault because अगर wire C पर कोई fault है, it is not affecting the wire B. Similarly, it is affecting wire D. The fault out equivalent. So we should consider all the faults. So all the faults are considered as it is. When it comes to NOT gate, a stuck at 0 fault at input is stuck at 1 fault at output. Similarly, is equivalent to stuck at 0 at output. So for fault collapsing, for equivalent fault collapsing, we eliminate the faults towards inputs. So I eliminate 2 and I am with stuck at 0 and 1 at the output of the NOT gate. This AND gate, the lower AND gate, again stuck at 0 faults at input need to be eliminated. So now I eliminate stuck at 0 here and here. I am left with stuck at 1s at input and 2 faults at output of this AND gate. Lastly, I look at this OR gate. OR gate में क्या होता है? Stuck at 1 at input is equivalent to stuck at 1 at output. Here, stuck at 1 at input is equivalent to stuck at 1 at output. So I eliminate the stuck at 1 fault at input. So stuck at 1 fault at input eliminated and I am left with only these. If I count these faults, it would be 1, 2, 5, 6, 7, 8, 9 and 10. So all 18 maximum fault possible. After equivalent fault collapsing, I only consider 10. So the collapse ratio is 10 upon 18, which is 0.556. So almost 50% of the faults are eliminated. Further, we can reduce the fault list by eliminating the dominant faults. Dominant faults क्या होते हैं? If F1 is tested with the test pattern T1 and F2 is tested with test patterns, set of all test patterns T2, and T1 is a subset of T2, then we say F2 is dominant and we eliminate this F2. Right? So if we look at the AND gate, इक्विवेलेंट कोलैप्सिंग के मेरे पास क्या बचा? Stuck at one fault here, stuck at one fault here, and the two faults at output, stuck at 0 and stuck at 1. At 1 at input was tested with what test vector? 0 होना चाहिए ना यहाँ पे, तो 0 1. This was tested with 1 0. Stuck at 0 will be tested with 1 1, and stuck at 1 will be tested with 0 0 0 1 1 0. So if I look at these test vectors now, the test vector 0 1 is a subset of this. So I can say all the test vectors which are required to test this stuck at 1 fault can detect this fault as well. Therefore, I eliminate this fault. Right? Similarly here, test pattern 1 0, which is a subset of this test pattern, right? Stuck at 1, these stuck at 1 at input. So after dominant fault collapsing, I am left only with the 3 faults as compared to the initial 6 faults possible on the AND gate. Right? So now use this procedure on the left out faults. If I look at this AND gate, I am left with stuck at 1 at and stuck at 0 at output. It is already minimized. I cannot eliminate any of the faults. So these 3 faults will happen. If I talk about this fan out, again, no more faults are dominant because the stuck at 0 here will be not a stuck at 1. अगर यहाँ पे मेरा stuck at 0 है, then the value will again be stuck at 0 at wire C as well as D. But if I have a stuck at fault at C, that does not change anything at B. Right? So nothing is dominant. So the fault list remains as it is. For the NOT gate, I am already left with only one stuck at fault, so it cannot dominate any other fault at the NOT gate. So this remains as it is. Talking about this AND gate, I have 2 stuck at 1 faults at input and only stuck at 0 fault at output. So this is already minimized. Nothing removes here. But if I look at this OR gate, now I have stuck at zeros at input और output with stuck at 0 or stuck at 1 दोनों है. So if I apply this way of finding out the dominant faults, I will find out that this stuck at 0 was detected with 1 0. OR gate का stuck at 0 was detected with 1 0. This will require 0 1. Stuck at 0 किससे आ रहा था? 1 0 1 1 0 1 से नहीं ओके स्टक एट 0 और स्टक एट 1 किससे आता है? 0 0 से. So if I compare these now, so this stuck at 0 and this stuck at 0, इनके test pattern lie completely here. Therefore, I can eliminate this stuck at 0 fault. So I eliminate this stuck at 0 fault from my fault list. So if I try to find the collapse ratio now, after dominant fault collapsing, this comes out as one more fault eliminated. So I have total 9 faults that need to be worked upon, divided by the maximum fault is 80. So only 50% faults need to be taken care of when we apply ATPG algorithm on this combinational circuit, so as to determine what test patterns should be used for covering the entire list. Right? The question will appear in the form of to identify the collapse fault list and may be asked to calculate the collapse ratio. Abhi clear hai? Is this question okay? बोलो. Look at the second question. Or bridging fault. Slides are visible?
Yes, ma'am.
Okay. So look at the second question from your assignment. It asks you to find the test pattern when there exists a bridging fault. Or bridging fault है and है. What does your assignment say? And it is very difficult for me to switch the window again and again. You need to tell me. Or bridging fault between wires A dash and B. So A dash and B, it means here I have an or bridging fault. Or bridging fault simply means that either of the two value can be seen on this wire as well as this wire. दोनों पर होगा same ही value, but instead of reading the value of this wire as A dash, now the value of this wire will be, faulty value will be A dash or B. Similarly here, it will be A dash plus B rather than simply B. Right? So when we have a bridging fault and we are required to find the test pattern, we need to use the formula that the primary output Z XORed with the faulty output Z is always true. या तो output non-faulty होगा or it is faulty. So either of the two conditions is true, then only the output is 1. अगर दोनों 0 0 होंगे XOR gate में तो output 0 होता है, दोनों 1 होंगे then also output is 0. So it is never possible. So first we find out what is the expression of this output E without fault. Find out what is the Boolean expression for E. ये तो जल्दी से हो जाना चाहिए.
A dash B plus C.
A dash B plus C. What will be the faulty expression E? It means you consider this wire as A dash plus B, this wire as A dash plus B. Right? तो यहाँ से तो A का A dash आया fine, but now the value at this AND gate becomes A dash plus B. So what will be the output D equal to? A dash plus B only. ठीक है? So how can I write EF? The faulty value of the faulty expression of E, it would be A bar plus B from this input of OR gate plus C from here. So I have the expression for E, I have the expression for a faulty E. Put in the value E XOR EF gives me 1. That simply means A bar B plus C XOR with A bar plus B plus C equal to 1. Bracket खोल लो, Boolean algebra use करो. So A into B bar, which is A bar plus B plus C का bar, plus A bar plus B plus C as it is and complement of A dash B plus C. This should be true. This gives me A dash B plus C into ये क्या होगा A B bar C bar. Complement of this would be A B bar C bar plus A bar plus B plus C as it is. ये क्या हो जाएगा A plus B bar into C bar. If I multiply these two terms, this will always give me 0 because first term will be A dash into A. So A dash dot A is always 0. Here C dot C dash, that would be 0. So I am left with this part. A dash into A will be 0. So what do I get? A dash, B dash, C dash plus A B C dash plus B dot B bar 0. So I'm not writing it. Then I have C into A into C bar. That will all be 0. Right? So I'm left with only these two parts. Is it so? Okay, so we need not solve it. So what are the test patterns that I get? 1, 1, 0 and 0, 0, 0. These two test patterns will be able to detect the bridging fault or bridging fault at A dash and B. ये check करो solve सही किया है क्या? So the only two test patterns are able to test this bridging fault, that is 110 and 000. Is it okay? Look at the third question. You have to determine the test pattern to detect the AND bridging fault between wire A and C. You have an AND bridging fault here. AND bridging fault का मतलब the value at this wire is no more A but A dot C. Similarly, the wire here will give you the value A dot C. Find out the expression of J without this fault, that is take the value as A and C independently. And the second time, find the faulty value of J by considering the input as AC here. Find out what is J. ठीक है? Is it okay? Purva?
Yes, ma'am.
Okay. Find out the faulty value. So J comes out as AB plus B bar F, and the faulty value of J will be given as, instead of having this value as a dot b, what will it be? It will still be a dot b, because now here it is AC, faulty value. Both the inputs are AC, so the output of the AND gate will also be AC. C is equal to B, so the value is AB. So JF is again equal to AB plus B bar F. So the function J comes out as JF, which simply means this fault is undetectable. There is no test pattern which will be able to detect this fault. So the AND bridging fault between the wire A and C cannot be detected at the output. Okay? Quickly looking at the last question, you are required to find the collapsed fault list. So it consists of AND gate, NOR gate and OR gate. So use the equivalent faults and dominant fault, and you can reduce the fault list. Left to you is an exercise. If you have any problem, ask me on WhatsApp or during the class, and if you want your work to be checked, then upload it in the assignments. It does not carry any marks and it is not compulsory to submit the assignment. But अगर तुमको लग रहा है कि हाँ जो किया है that I should check, then you only upload it and then I'll see if the work is done sahi or not. ठीक है? And tomorrow what we will, next class we will be doing ATPG algorithm for combinational and sequential circuits. The next tutorial will be on ATPG for combinational only. Let's take for combinational. ये जो circuits हैं, the circuit are the same that we took in the last class, only the problem is different. So you can work out with all the problems on all the circuits, right? So try yourself for different cases. That is all from me for today. Anything anyone wants to ask? Fine. The assignment sheets are available with you. You can look at it anytime and practice those questions. कल वाला assignment दिख रहा है अभी या it is closed? अरे तुम मेरी बात का जवाब नहीं दोगे तो फिर मुझसे क्वेश्चन पूछते रहना एंड टर्म के लिए जब फिजिकल होगा मैं भी तुम्हारे क्वेश्चंस का आंसर नहीं दूंगी. You may leave the class. I am ending the meeting.